Hello everybody, my name is Alberto Marquez. In this video we are going to talk about more operations using vectors inside R and RStudio, and particularly we're going to talk about how to add, subtract, multiply, etc. So this is the specific of what we are going to do right now. We are going to create two vectors and then we're going to add them. We are going to multiply. When we say we add them, we add element to element. When we say we're going to multiply, we multiply element to element. If we are engineers, we know that there are the type of operations in terms of what it means to be multiplying vectors, but in this particular case we're just multiplying element to element, and we're going to be using powers and computing some basic statistics on the vector components, which could include the summation of the values, the mean, the standard deviation, and computation of elements like the minimum or the maximum element inside the vector. So let's do that. Here we are in RStudio, and the first step we're going to do is create those vectors that we're going to be using. So I make the assignment. Vector 1 is going to take the values. Remember, we use C for that, and it's just going to be 1, 2, 3, and 4. The second vector, vector 2, is going to be assigned the values 2 and 2 and 3 and 3, and we can verify the values just by typing vector 1 and vector 2. Now we can add them together, vector 1 plus vector 2, and you will see that the output that is produced is precisely the element to element addition of each one of the. We can do a similar multiplication, vector 1 times vector 2. Notice that if I add the spaces between the operators, it's more readable, so maybe that's a good practice when we are writing code. And there you go. We can even use powers, vector 1 raised to the power of vector 2, and again element to element. The numbers are on screen. There are the functions that we can do, like adding all the components in the vector. So the sum of vector 1 is 10. 1 plus 2 plus 3 plus 4 is 10. The mean, or the average value of those, is mean of vector 1, 2.5. The standard deviation reduced notation or function is vector 1 SD. And finally we can compute the maximum, for instance, or the minimum. So it is very easy to create these statistics. Now we're going to move the discussion in a different direction. We can do arithmetic operations like multiplication and so forth, but we also can compare, and comparing is important because when we compare we can begin to make decisions in a script, in a program, that would allow us to automate our processes. So essentially, when we make a comparison, the output is a Boolean value that is either true or false, and when I compare, say for instance 3 is less than 4, the value is true, and if I say 3 is larger than 4, then it is not true, it's false. To make comparison in R, you need to use a double equal sign when you're comparing to be equal. There is no single equal assignment. For the assignment we use the combination of the less than or equal and the horizontal line there. So in order to make sure that we want to make a comparison, instead of using 1 equal, we use 2 equals in order to compare. And if we compare 3, if 3 is equal to 4, of course that's going to be false. Notice that because we're using the same characters, if we misplace the dash, we're going to have problems. The statement m dash and then continued immediately less than or equal than the dash 5, it makes the assignment of 5 into the variable m. Whereas if I insert the space between the less than or equal to sign and the negative sign, then what it's going to do is going to compare m to the value of -5. So, and the output is going to be false. In this case, because we just assign positive sign 5 to the value of m. So we need to be careful with these operators. Similarly, we can do the comparison of element to element in vectors, and the output is a vector of logical expressions. It could be either true or false. So we can do that, and also valid are larger or equal to, less than or equal to, and not equal to the that expression sign, and then the equal means that it's not equal. So let's do that in the studio. Great, so here we are, and if we compare is 3 less than 4, the output is logical true. Is 3 larger than 4 is false. Is 3 equal to 4, and we're posing a question, is not true. Now if we make the assignment in m, we're going to be assigning the value of 5. Here we are making the assignment. Now the value of m is 5. Now if I compare to -5, the typing would be, is this less than -5? Less than -5. And the only difference is the space. And then I get, no, it's not, because m is 5. Very good. Now we had our vectors before, vector 1 and vector 2. So I can compare vector 1 equals vector 2, and the values are false, true, true, and false. As a reminder, let's see what the vector 1 was. Vector 1 was 1, 2, 3, 4. Vector 2 was 2, 2, 3, 3. So the first and the last one are false, but there were 2 in the middle, and that's it. That's we can assign that to a vector. So we can, I think we can do that. Let's try my logical vector v, logic v. We're going to make the assignment of vector equals to 1 equals to vector, and probably we're going to need this. Let's try. We didn't have any errors, so let's see what the content of logic v is. It's a vector that contains those values. So the logical values of the output of the comparison between vector 1 and vector 2 being equal or not. Great, very good. Now we can identify the particular components inside the vector by using the index. The index in the vector is wrapped in square brackets, and we can also identify the more than one if we make use of two of them, and we can select a range of them by using a column. So let's see, let's try. Also, we can use names to index the. We have seen names before. We can identify the particular elements using the names. So let's try doing exactly this. All right, we're back in RStudio. Let's space, and let's start with a vector. We're gonna call it, for the sake of simplicity, v3, and we're going to assign the values 3, 6, 9, 12, 15, 18, 21, and 24. v3, that's our vector. Now we wanted to identify, say, the vector, the element in position number 3. We go to v3, and then inside that 3, inside that vector 3, we want position 3, and that position 3 is 9. The element in position 7, very good. Now we can identify a series of them that are in continuous form by doing v3 is anything, let's say for instance between 3 and 6, and the elements that are in position 3, 4, 5, and 6 are 9, 12, 15, and 18. Okay, and now we are going to use the names in order to index. Remember, we have v3 is this, and we're going to create a vector of names for this vector. So let's say our new vector of names is going to be, let's say, users. I'm going to use vector, and I'm going to assign the following names. The names are Jim. I need 8 names. Joe, Joel, John, start with the quotation mark, Johanna, John, James, Jeremy. We have 8. 1, 2, 3, 4, 5, 6, 7, 6, 7, and 8. So we have 8 users in let's see, vector users right there, and then we're gonna use those users as the names to identify as identifiers for the data in v3. So what we do is names of v3 is going to be assigned from v users, such a way that if now I say v3, I can see the corresponding name on top of the data. Great. Very good. Now what we're going to do is we are going to create a subset of the information inside this vector 3, and we can use the operators, the comparison operator, to create that value. Let's say, for instance, that I am interested in the elements in the vector 3 that happens that the vector in vector 3 are, say for instance, larger than, I'm going to say, okay, and the elements that are larger than 11 in v3 are anything that is above that, of course, 12, 15, 18, 21, and 24 only. Now we can store that information in a vector. There are other things we can do. The way that we did this is we immediately identify the values, but what we can do is we can create a vector of what happens when we just compare them. So if we do what happens if we compare v3 against b larger than 11? We get that the first three are false. 3, 9, 3, 6, and 9 are smaller than 11, and then starting from 12, all of them are true, and that's a vector of comparisons that we can store in a vector. And let's use b4 as that vector, so we can store in b4 the vector of booleans when we compare b3 against 11. b4 now has that value of vectors. Notice that the names were transferred from b3 to b4, so that makes it easy for us to remember what we were talking about. And then we can create another vector. Vector 5 is going to be vector 3, and the criteria is to include them or not. If they are in vector, if vector 4 is true. So only when it's true we're going to include them. If we list b5 now, only those that are larger than 11 are included. Great. Hey, I was forgetting to make the reference to the particular element inside the vector by using the names. So let's say if I select b3 of Jim, the value is 3. Good. Now with this we finished the discussion on this video about vectors, and we're going to move forward other concepts. Thanks for watching this video.